Okay, let's give a little bit of background on waves and kind of how they work. This is going to be related to light because we're going to think of light kind of as a particle or a wave, and we'll talk more about that in class. But right now we want to think of kind of how we describe waves. It could be sound waves, light waves, water waves, waves on a slinky, the wave. The whole idea of this is that waves are kind of periodic. So for example, this here is periodic, and by that I mean I can spell periodic. Periodic. And basically, I mean by that is that it repeats itself. So like the wave is not exactly periodic, but most of the other ones are pretty periodic. We have a medium. So in this case, the medium is going to be this line. This might be slinky. It might be people's hands. It might be air. It might be water. And so, if it's a slinky, it can refer to, the height or displacement of the slinky. If it's people, it probably refers to, height of hands. If it's water, it probably also refers to height again of water. But air can be kind of weird, tends to refer to pressure. Also probably doesn't look like this, but it's neither here nor there. Alright, point is, if we have this wave, we want to try to be able to describe what it means to have a wave structure. So we think of this as being a picture of a wave. So it's a picture, so a snapshot. So this is at some time. And so if we look at this, then, this is a picture of it. So that as we move left to right, we're looking at positions. So this, from peak to peak, is what we would call the wavelength. It is coincidentally the length of our wave. This, from kind of the middle to the top, is what we would call the amplitude of our wave. So from top to bottom is twice the amplitude. But now the interesting thing about a wave is that it moves. And it moves not that like the whole wave gets up and moves to the left, but so in the next second, the wave will have a shape that looks kind of like this. Except probably more likely, more like the actual shape it will have. And so this little spot here has gone up. This little spot here has gone down. The wave, all of these points don't move left to right really if the wave is going up and down. So like if the wave seems like it's moving left to right, the water, the hands, the whatever, they're moving up and down. So if you think of the wave, your hands go up as my hands just did, and then they go down. But the wave seems to move to the right or to the left. That's kind of one interesting bit about waves. So that means that there's another way to think about this. Maybe we want to think about what's going on for one spot. One spot, not on spot. So this is maybe, a stadium that's doing the wave and it keeps doing the wave. So, your hands go up, your hands go down, your hands go up. Your hands probably also go down. And so this is only your hands. Which means that we're not looking at kind of, this is no longer position, but now we're thinking this is time, going left to right. So this, from peak to peak, this time from peak to peak is the period. It is the time for one cycle. This, still twice the amplitude of our wave. And so there's a couple relationships that are interesting to talk about. Also, going back up for 1 second, this whole thing here where the wave's moving, there's then some wave velocity we want to talk about, the speed of the wave. So, when we're talking about these things, we have a wavelength, which we'll tend to call lambda. We will have a period, which is the time between peaks. Wavelength is the distance between peaks. We will have a wave speed or a wave velocity. There's a wonderful thing that happens where the wave speed is the wavelength divided by the period. So basically, it's how long it takes for it to go from peak to peak, kind of. There's also one other thing that we kind of talk about related to the period, and that is the frequency. It is going to be 1 over the period. And so what this is trying to talk about is, so if a wave comes by, imagine it's like the beach. A wave comes by every 2 seconds, so the period is 2 seconds. Right? That means that there is 1 wave per 2 seconds. The frequency is 0.5 waves per second. So, wave every 2 seconds. 2 seconds is the period. 0.5 waves per second. This would then be the frequency. But they're saying the same thing, kind of. When we talk about wavelength, frequency, and period, these are all going to kind of be related. For light, for example, we would say that this is true, where c is the speed of light, and that's fixed. What that means is that for a given wavelength, there's only 1 frequency. And vice versa. For any frequency, there's only 1 wavelength. So when we describe light, we talk about it in terms of its wavelength or of its frequency, assuming we're thinking about it in terms of a wave model. So, quick review. We have a wave. If we look at it as a picture in time, then this is kind of, distance being measured left to right. We're talking about a wavelength here, and the wave moves from one time to another if we take a sequence of snapshots. If we think of it in terms of one position, maybe you're doing the wave, these are your hands going up. Maybe you're standing in the ocean and your head is, over here, and whoops, you're getting a wave in the face every so often. Anyway, that's a really weird example. Think of the wave, with hands going up. Then this is one spot that's looking, and we're just saying as time goes by, as it goes up or down. And we characterize these things in terms of their wavelength, their period, their velocity, which we don't use graphically, is kind of tough to represent, and their frequency. And frequency and period are inversely related. If you have a high frequency, that means the period is small. High frequency, many events per second, very small time between events. Whereas if we have a low frequency, then there's a high period. Low frequency, few events per second, lots of times between events. Yeah. In class, we're going to talk about a couple of different examples of this. We're going to talk about the Doppler effect. We're going to talk about wave interference. But this will kind of give you a little bit of a framework to begin discussing it.